Good morning, students. Today we have to discuss two important concepts and their measurement. These concepts have already been introduced in the semester 1, especially for discrete frequency distributions, and these are skewness and kurtosis. You know that skewness means it is a departure from the symmetry. It is a synonymous word to asymmetry. It is a Latin word. When the frequency curve of a random variable is not symmetric, then we use the concept skewness, and in such cases we are interested to know how or up to what extent the curve is asymmetric. And also we are interested in the height of the frequency curve. More is the height of frequency distribution, that indicates more is the concentration of observations around the point of symmetry, and smaller value of the height or flat topped curve means the concentration at the middle value, that is at the point of symmetry, is low. So these two concepts we have already discussed in the last semester. So when we want to differentiate between symmetric and asymmetric distributions, or among asymmetric distributions, we use coefficients of skewness. Or if we have many distributions which are symmetric and we want to differentiate among them, 4, 5, 6 असे वेगवेगळे फ्रिक्वेन्सी डिस्ट्रीब्युशन्स आहेत, ते सगळेच्या सगळे सिमेट्रिक आहेत, they all are symmetric at the same point of symmetry, then how to differentiate that, याच्यासाठी आपल्याला कुर्टोसिस वापरता येते. तर या ज्या दोन कॉन्सेप्ट आहेत त्याचा अभ्यास ऑलरेडी तुम्हाला BSc पार्ट 1च्या सेमिस्टर 1मध्ये इंट्रोड्यूस झालेला आहे. आता we use the same concepts, but here in the context of probability curve. Here we have a random variable and we have probability distribution of that random variable. So for every PMF we can draw a probability curve. We can draw a probability curve, and if that whether that curve is symmetric or not, and if it is not symmetric, then up to what extent there is asymmetry, we can study using coefficients of skewness. So Pearson's coefficient of skewness, we will keep the notations same as you have already studied. First of all, see Pearson's coefficient of skewness. Let x be a discrete random variable taking values x1 to xn with probabilities p1 to pn respectively. Then Pearson's coefficient of skewness are defined as beta 1. Beta 1 is equal to mu 3 square divided by mu 2 cube, where mu 3 is third order central moment and mu 2 is second order central moment. Since we are taking square of mu 3, it will always be a positive quantity. Mu 2 itself is always positive, so cube of any positive quantity is always a positive quantity. Therefore, the beta 1, both numerator and denominators are always positive. So the value of beta 1 will always be a non-negative quantity. It will never be a negative number. So we can take further to make the unit of measuring skewness by taking square root. By taking square root of this beta 1. So gamma 1 is equal to square root of beta 1 with algebraic sign of mu 3. The beta 1 is always positive, but its square root can be a negative as well as positive quantity. So gamma 1 will be negative if mu 3 is negative, and it will be positive if mu 3 is positive. So the sign of gamma 1 depends on mu 3. So by computing second and third order central moments, we can compute beta 1, and from the beta 1 we can compute gamma 1, and based on these two coefficients we can interpret the results. What it indicates: if beta 1 is equal to 0, if beta 1 is 0, then gamma 1 will also be equal to 0. So this implies priority distribution is symmetric. Priority distribution is symmetric. So 0 value of beta 1 as well as gamma 1 indicates priority distribution is symmetric. Or inversely we can say if the priority distribution is symmetric, then the value of beta 1 as well as gamma 1 will be 0. So the converse of this statement is also true. If beta 1 is strictly greater than 0, beta 1, if it is strictly greater than 0, then there are two possibilities. One possibility is that gamma 1 can be negative and gamma 1 can be positive depending on the sign of mu 3. So if beta 1 is greater than 0 and gamma 1 is also greater than 0, that means mu 3 is positive, priority distribution is positively skewed. That means its tail is more elongated along positive x-axis. So probabilities increases suddenly and then decreases slowly. If beta 1 is greater than 0 and gamma 1 is less than 0, that means gamma 1 is negative and it will be negative when mu3 is negative. So in this case, priority distribution is negatively skewed. So always it is better to use gamma 1 coefficient to interpret the skewness. So gamma 1 0 indicates symmetric distribution. Gamma 1 negative, negatively skewed. Gamma 1 positive is positively skewed distribution. So in this way we can use the coefficients of skewness due to Pearson to interpret the results of priority distribution regarding symmetry. Similarly, we have seen also other concept what is called kurtosis. Now the kurtosis, it can be used to differentiate among all symmetric distributions. If we have many candidates which are symmetric at the same point of symmetry, then we can use kurtosis to differentiate among them. Let x be a discrete random variable taking values x1 to xn with probabilities p1 to pn respectively. Then Pearson's coefficient of kurtosis are defined as, it is denoted by beta 2. Beta 2 is equal to mu 4 divided by mu 2 square. Mu 4 divided by mu 2 square. Mu 4 means fourth order central moment, and mu 2 square is second order central square, second order central moment mu 2 and its square, and gamma 2 is equal to beta 2 minus 3. Okay, so we can use these two coefficients to interpret the results regarding the kurtosis. If the values of beta 2, if the value of beta 2 is equal to 3, if beta 2 is equal to 3, then gamma 2 will be 0. So priority distribution is normal or mesocurtic. Priority distribution is mesocurtic, which is having height equal to a standard normal curve. Is height equal to normal priority curve. If beta 2 is greater than 3, which is equivalent to gamma 2 greater than 0, and this implies priority distribution is leptocurtic. Leptocurtic means the priority curve is more peaked at the point of symmetry. And if beta 2 is less than 3, which is equivalent to gamma 2 less than 0, that means gamma 2 is negative, then priority distribution is platycortic. That means the height at the peak of the priority curve will be shorter than normal curve. It will be a flat curve as compared to normal priority curve. So in this way we can use these four coefficients beta 1, gamma 1, beta 2 and gamma 2 to comment regarding skewness and kurtosis about the priority distribution. So these are the four coefficients. For any given priority distribution we can compute their values and we can interpret the results. In the subsequent lectures we will see how to obtain these coefficients for given priority distribution. Okay, so let me revise what we have seen today. We have discussed Pearson's coefficient of skewness and kurtosis. These four coefficients, 2 for skewness, beta 1 and gamma 1, and 2 for kurtosis, beta 2 and gamma 2, and their interpretations. Okay, so see you next time. Goodbye.